Okay, Assalamualaikum and very good morning to everyone. Okay, so today we will talk about, we continue our subjects, okay, our topic today for CSC429, okay, which is a chapter 2 about the numbering system, which is how your data can be represented in the computer. Okay, so in the previous class, you already learned about the component of the computers, okay, the architecture of the computers. Okay, now we look into the how your data is being represented in the components. Okay, all right. So it will be related with your numbering system. Okay, now this is the overview. Okay, of the topic. You were introduced about how the number systems is related with your computer system. Okay, and then you will perform some arithmetic operations, okay, in the different numbers of bases. And we have alphanumeric representation, the binary code decimals, the unsigned numbers, and representations of the signed numbers, and how the IEEE floating point representation. So these videos will cover only some from the first introduction until the additions of numbering system. Okay. Okay, since you are learning, okay, start learning in the kindergarten, okay, until now, okay, you are always running with the numbers, okay, we are dealing with the numbers every day, okay. So when we see that the numbers, you can see the numbers 1 until 10, 1 to 100, 1 to 300, okay, that's numbers is we call as decimal numbers, okay, which is a base 10. So the base 10 number representations, okay, now we that's why we can fingers, okay, so kita boleh kira, okay, jadi kita boleh kira 1 sampai 10, 10, 11, 12 dan seterusnya. So bila kita biasa pakai nombor numbering system, okay, kita boleh nampak penggunaan number tu dalam kehidupan kita sehari-hari. Okay, jadi dalam ni kita akan tengok bagaimana nombor biasa, okay, dari base 10 ni, macam mana dia bertukar menjadi nombor di dalam computer system. Okay, and the natural representation for the normal kita pakai kat mana? Kita banyak pakai untuk financial transaction. Okay, kita nak buat cap paying kita punya banking. Okay, so banyak. So sometimes waktu kita beli barang pun kita ada floating point number. Okay, which is can be cannot exactly represent RM1.20 gitu So even they have a carry in the scientific notation. Okay, kalau yang complicated, kita akan tengok number tu dia akan have a scientific notation. Okay, with 1.5213 times 10 to the power of 4. Okay, yang ni kita boleh nampak kat mana? Kita boleh nampak dia dekat dalam kita punya calculator. Okay, so kita hari-hari kita deal dengan this kind of number. Tapi dalam elektronik, okay, susah kita nak simpan numbers base 10 ni. Okay, yang kita nampak, yang kita type tu is the numbers. Okay, basically bila dia dalam komponen, bila dia dalam hardware, okay, dia bukan lagi dalam the number base decimal number yang kita nampak. Dia akan bertukar menjadi satu number yang lain, we call a numbering system. Nanti kita akan tengok dalam binary number. Okay, sebelum ni kita tengok computer, the first computer, okay, electronic computer is ENIAC pun, okay, they use the color sebab dia nak dealing with the decimal number dulu, dia perlukan 10 the vacuum tubes. Okay, untuk 10 digit number tu, dia perlukan 10 vacuum tube. Bayangkan kalau dia nak buat calculation yang besar lagi. Untuk 1000, 2000, okay, 100,000, 1,000,000. Okay. Right. So, therefore, okay, it's very hard for you to transmit, okay, data for using decimal numbers, okay, and very high precision, okay, untuk encode pula 10 signal levels of the single wire, okay, so it's very difficult for you to use this decimal number, okay, for secara electronically, okay, di dalam komponen computer, so it's very messy. Okay, to implement digital logic functions dalam base numbers. For contoh addition, multiplications. Okay, kita nak komputer kita cepat processing. Bila you punya computer processing you menggunakan number yang quite big, okay, it's very hard for your computer in order to process, okay, your computer much faster. Okay, so that's why dalam topik ni you akan nampak, okay, beberapa numbering system, okay, that being used by your computer. Okay, antaranya ialah binary representations. Okay, how your numbers is represented in the binary number, or we call it as a base 2. Okay, so they represent in the digit of 1 and 0. So the electronic can be implemented much easier using a base number because they are representing into 2-digit number, which is 0 and 1. And easy to store with the bistable element. Okay, ini secara electrically, okay, macam mana the signal, okay, data and the some signal tu dia akan masuk ke dalam komponen, and then dia tak perlu, it's easy to transmit and reliable for you to transmit on the noise and accurate wise. Okay, alright. That's why kita katakan electronic, okay, is electronic devices. Komputer tu sebagai electronic devices. Sebab semua data, semua semua data yang ada di dalam komponen komputer di dalam komputer adalah menggunakan digital. So dalam digital system, the number will be represented in the bits, okay, with the smallest unit of data. So the bits is represented from the binary digit. So it is a single digit in the binary number. This is represent 1 or 0. And inside your computer, you can think of the bit as a being mechanical switch. Okay, dia macam, that's why dia lebih mudah. That's why digunakan ni, sebab sebelum ni you dah belajar di dalam komponen komputer, all the ICs is represented by the transistor. So resistor, they have two possibility, on and off, yes or no, okay, 0 and 1. So that's why they can use, that's why they use a binary number or the digit number in order to switch on and off, okay, for your electronic components. Okay, selain daripada bits, okay, we also have the byte. So byte ni actually is the bit, is the 8 bits of group together. So you have a 8 bits, you have a 8 bits that we group and store, okay, in one we call as a byte. So one bit is 1 byte equivalent to 8 bits. Okay, so when they store the values, the numbers, okay, so the 8 bits can be between 0 and 255. Okay, so they counts with the 256, but it start with the 0. So the combination of 1 and 0 to choose, okay, sama ada dia start dengan kosong ataupun 1 bergantung. Tapi dia punya the maximum values for the 8 bits adalah 256. Okay, so the values will start from 0 until 255. So the original intention was that 8 bits would be enough to assign a unique number and a very possible language character. Okay, sebab kita one character can represent by the 8 bits or 1 byte. Okay, we can count it as a 1 byte. Okay, another definitions okay, about the numbering, okay, about how your data can be represented is by words. So words actually a data can be handled by the processor at a time. So berapa banyak words it can be handled and can be processed by your processor dalam satu masa. Okay, so the most common word size, okay, adalah 8, okay, 8 words, okay, 16, 32 and 64 bits. Okay, dia bergantung kepada processor. But nowadays, kita tengok kita punya processor is covered with the 32 bit and the 64 bits. So that's why you punya processor, you akan tengok processor you boleh ada 32 bit ataupun 64 bit. So they were dealing how your processor can handle the data at one time. Okay, kalau dia 32 bit, so the number of 32 bits sahaja yang dia boleh proses dalam satu masa. Kalau the processor with the 64 bits, means that dalam satu masa dia can handle your data in the 64 bits. Itu maksud dia. Okay, this is how your data can be presented. Okay, so 1 bits, either 1 or 0. When you group together in the 8 bits, it become 1 byte. And so, and 1 words is combinations of 2 bytes or 16 bits. Okay, right. So 1 word is equivalent to 2 bytes or equivalent to 60 bits. So ini kena faham istilah-istilah bits, bytes and words. Okay, alright. Okay, this is the number basis, okay, that we will introduce to you. Okay, decimal number is normal number that you already learn, okay, how to use it. And then now kita akan tengok how your data can be presented in the binary form, in the octal and also the hexadecimal, termasuk the floating numbers. Okay, so the float numbers is also included. That's why when you are doing your coding and when you are doing your programming, so when you do a code, okay, that's why you have to declare the variables. Okay, so the variables, the numbers itself have the range. Each of the range, they have a different color. Float, okay, they have a range. Double, okay, they have the range there. Okay, long integer, for example, they have a range of the values or numbers that can be did when they do the processing of your code. Okay, alright, so these are numbers of bases. Okay, so how the numbers of bases in the decimals, okay, in the binary, okay, in the octal and also the hexadecimal. So binary is a base 2, octal is a base 8 and the hexadecimal is a base 16. Okay, so kalau kita tengok dekat sini, this is a decimal number. So the binary, okay, you have 0 and 1 sahaja. Okay, untuk octal, they start with the 0. And then because the base 8, okay, so the maximum is 0 to 7. Okay, the sama macam decimal number. Tapi apabila dia start dengan dengan 8, nombor 8, okay, in the octal basis dia bukan lagi 8. Okay, dia akan jadi 1, 0. So dia akan reset the left one to 0 and they put the additional digit, okay, in your left. Okay, so they have 1, 0. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. Sampai sini je. Bila dia 16, 1, 8, dia tak ada 1, 8. Okay, dia akan start back with the 0 and put another additional on your left side of the digit. So, dia jadi 20. Okay, never mind. Kita akan tengok macam mana how it can be generated. Okay, and then the hexadecimals, okay, you have a base 16. Okay, base 16. So, you have base 16. So, they start with the 0. Okay, the numbers until 15 is same. Until the 15. But, unfortunately, dalam hexadecimal, okay, the 0 to 9, okay, are same as your decimal numbers. Okay, but start with the number 10, okay, nombor 10 ni, okay, dia akan start with the letter, okay, which is A, represent by 10, B, represent by 11, C, represent by 12, D, represent by 13, E, represent by 14, and F, represented by 15. Okay, so if dia nak buat 16, nombor 16 macam mana? So, nombor 16, dia akan reset back 0, and then dia put additional F, 1, 1, 0. Okay, sampai dah habis. Okay, alright. Kita akan pergi go through macam mana kita nak generate, how to convert from the decimal to binary, how to convert decimal to octal, okay, how to convert the decimal to hexadecimal, okay, and vice versa. Okay, alright. Okay, now we look into how we convert, okay, our decimal number to the binary. Okay, so in order to convert binary to the, okay, decimal to the binary, you have a two ways. Okay, you can choose either way. Which is one more comfortable, either using a placing value method or using a division method. So placing value method is based on the basis either using a binary, octal or hexadecimal. Okay, boleh pakai untuk other basis, but it's quite difficult. Okay, susah sikit. Okay, alright, and division method is, okay, generally can use any basis. You nak base 5, you nak base 7, you nak base 12, you nak base 3 ke, ataupun you nak base 4 ke, pun boleh. So, division method is more general, okay, to use in, you can convert any decimal numbers to the other bases. Okay, alright.